So let us work on the following exercises. The simplest way of evaluating the limit is by substitution method. No? Substitution method. What you do is you simply substitute a to f of x. So it's just f of a. But we are not saying that f of a is the function value. No? So that is the simplest way, because it's not always that you can substitute a to x in f of x. And examples of such, no, wherein the substitution method fails will be given later. So for now, let us solve the following. So the limit of the quantity 7x squared minus 4x plus 5 minus 3 over x as x approaches 1 is equal to 7 times 1 squared minus 4 times 1 plus 5 minus 3 over 1. So that is 7 minus 4 plus 5 minus 3. That is 7 and 5, 12 minus 7, that is equal to 5. So please take note, once you have substituted 1 to all the x's, there is no need of writing the limit symbol. No? You need not write the limit symbol because you have already substituted a to x. Now the second one, the limit of the square root of 9y squared plus 8 as y approaches 1/3. So again, we simply substitute 1/3 to y. So 9 times 1/3 squared plus 8. That gives me the square root of 9. And we know that 1/3 squared is 1 over 9 plus 8. So we continue here. That will be the square root of 9 over 9 is 1 plus 8 is 9. So our limit is 3. Okay, the third one, we take on the limit of 5t minus 3 all over 2t plus 1 as t approaches negative 2. So we simply substitute negative 2 to t minus 3 over 2 times negative 2 plus 1. In the numerator, we'll be getting negative 10 and negative 3 or negative 13. In the denominator, it will be negative 4 plus 1 or negative 3. And that is equivalent to 13 over 3. We proceed to number 4. The limit of x minus 3 over x squared minus 9, okay, as x approaches 3. So by substitution method, that will be 3 minus 3 over 3 squared minus 9, which is equal to 0 over 9 minus 9, 0. But 0 over 0 is an indeterminate form. So in this case, substitution method fails. No? Substitution method fails. Because you cannot have an indeterminate form as an answer to a limit. No? Our limit must be definite. So we cannot have an indeterminate form. So going back to the problem, so let me now erase this. Going back to our problem, limit of x minus 3 over x squared minus 9 as x approaches 3. Notice that the denominator is factorable, no? Because it's the difference of two squares. We know that it is factorable into the sum and difference of their square roots. or it is equal to the product of x minus 3 and x plus 3. So we are still retaining the limit symbol, no? Because we haven't evaluated the limit yet. So it's important that we still write the symbol for the limit. So we are just rewriting the denominator as a product of the sum and difference of x and 3. And notice that x minus 3 can be cancelled. So that is the factor that creates the 0 over 0 expression, right? Because when you substitute 3 minus 3, that will be 0. Same thing for the denominator. But actually, it's not really equal to 0 because in this case, x is not equal to 3. No? Let us bear in mind that we are evaluating the limit and we are not calculating for the function value. No? So here, we cannot say that x is equal to 3. X is merely approaching the number 3, either from the left or from the right. So x minus 3 actually is not really 0. No? So we are dividing or we are cancelling x minus 3 and x minus 3. So what happens is that the function reduces to 1 over x plus 3 as x approaches 3. Now, we apply the substitution method. So 1 over 3 plus 3, and that is 1 all over 6. Okay? So how about in number 5? The limit of 2c squared minus c minus 3 all over c plus 1 as c approaches negative 1. If we are to apply the substitution method, what do we get? 2 times negative 1 squared minus negative 1 minus 3 all over negative 1 plus 1. So 2 times negative 1 squared is 2. Then negative of negative 1 is positive 1 minus 3 over 0. Again, we have an indeterminate form. And it cannot be. Huh? So by substitution, it results to 0 over 0. So what do? We try to get rid of the factor c plus 1. So you have the indeterminate form 0 over 0 because there is already a hint here, no? That there is also a factor c plus 1 in the numerator. So you know that one of the factors in the numerator is c plus 1. So how about the other factor? That will be 2c minus 3. Alright, so we check. C times 2c is 2c squared. C times negative 3 is negative 3c, and 1 times 2c is positive 2c. Negative 3c plus 2c is negative c. And finally, 1 times negative 3 is negative 3. Okay? So all over c plus 1. As you can see, we can cancel out the factor c plus 1. So we now proceed by applying the substitution method. 2 times negative 1 minus 3 all over. Okay, there is no more denominator because that's already 1. Okay, so let me rewrite this. It will just be 2 times negative 1 minus 3, and that will be negative 5. Alright? How about in number 6? We evaluate the limit of 27x cubed plus 1 all over 3x plus 1 as x approaches negative 1/3. So by substitution method, negative 1/3 cubed is negative 1 over 27 times 27 plus 1. And we know that this will result to 0. The denominator is 3x plus 1. If we substitute negative 1/3 to x, again, we will be getting a 0 in the denominator. So it will also result to an indeterminate form if we will use the substitution method. And so we have to get rid of the factor 3x plus 1, right? So we write here the limit of, okay, 27x cubed plus 1. It's the sum of two cubes. And one of the factors is supposed to be 3x plus 1. Okay, so algebra tells us that the factors of 27x cubed plus 1 are 3x plus 1, 9x squared minus 3x plus 1. Okay, so you can check on that. No, you review your algebra. Now we can cancel out 3x plus 1. X approaches negative 1/3. So now we have 9 times negative 1/3 squared minus 3 times negative 1/3 plus 1. Negative 1/3 squared is positive 1 over 9 times 9 is 1. Negative 3 times negative 1/3 is positive 1 plus 1. And so we have the limit equal to 3. Okay? So let me give you another set. Okay. So will you work? Will you work on these numbers? And then I'll be back after 5 minutes.